Hello everyone and welcome to my attempt on TSF Group Task 2, where our goal is to find the optimum number of clusters in the given iris dataset using an unsupervised machine learning algorithm. The unsupervised machine learning algorithm in question is the k-means clustering. Now, what is k-means clustering? It is an unsupervised machine learning algorithm and it attempts to classify data without having been trained with labeled data. Now, once the algorithm has been run and the groups have been defined, any new data can be easily assigned to the most relevant group. Now, we import all the necessary libraries that we need for this program and we read the CSV file that is uploaded to this Colab and we copy the path and we print it. And as you can see, I've printed the last 5 rows of the dataset. But as you can see, ID is also listed as one of the features of the dataset. This is not necessary for us and will bring us errors in the later time. So now because of that, we drop the ID column and we print it again just in case in order to see. And as you can see, the ID column isn't there. We also find the unique values of each of the species and print them here. Now, before we work on the data set, we check if there exists any null values in order to prevent confusion. If there exist null values, we fill them with the mean of that specific column so as to not change the data set as much. And as you can see, there is not any null values in any of the columns. Now, we describe the data set in order to learn more about it. That is like we have the number of observations, the mean, the standard deviation and all. Now, moving on to the k-means clustering, we need to find the optimum number of clusters that we need for the k-means algorithm to run successfully. For that, we use the within cluster of some squares or the elbow graph where we select the number of clusters when the change in the WCSS does not change as much, or the change is not as drastic as before. And as you can see from this given graph, 3 seems to be the optimum cluster here. Now moving on, as you can see, I've imported the dataset from the sklearn module, and if you print it, you can see that ID isn't already a part of it. But if you import the CSV file and you print 5 rows, you can see that ID is also a part of the features. And if I run the WCSS graph, you can see that the numbers have changed quite a bit. So that's not really optimal here. So now, as you can see, it also counts ID as one of the features and we get all these weird values because of that. So now that's why we drop the ID column in the original data set. Now moving on, we create a cluster classes based on the type of classes, that is 0, 1 and 2, and we fit them and we predict them. Now let us see the properties of iris dataset more clearly. And as you can see in this pair plot, we can see that Setosa seems to be the most distinct out of all the three, whereas versicolor and virginica seems to have a lot more in common. Now, we can see that how all the functions and parameters are correlated with each other using this heat map. And as you can see, the petal length and petal width centimeters do not seem to be as different. Now, these are various ways how you can see the probability density of a given species based on petal width centimeter, as you can see. And as you can see, Iris setosa has the most. And also, We can see the violin plot of the petal length centimeters, where the middle one, the white dot, as you can see, is the median, and the thicker line is the interquartile range, and the more thinner lines in the end shows the 1.5 times the quartile range. As you can see, this violin plot is quite detailed and it will help us a lot. But and moving on, we can see the box plot of the Seaborn library, which doesn't show as many as features as compared to the violin plot. But as you can see, the whiskers depict the interquartile range of each of the species, and the boxes show the median and percentile ranges. And now, as you can see, this is a bar plot that is constructed that shows the sepal width of each of the species. And as you can see, the clustered map shows the data points that is present in the data set. And as you can see, there's quite a lot of them, 150 of them actually. Now, moving on, let us find the k-means cluster of the given iris data set, where we use the matplotlib library, and we use the ident clusters that we found earlier in order to plot the graph, where we mark the centroids of the graph, here henceforth finding the k-means clustering of the given data set. Uh, Thank you very much for watching this video, and this is my first time, so I'm sorry if I've made any mistakes.